In this video, we are going to learn about semiconductors. Semiconductor is a type of material which have conductivity lie between an insulator and a conductor. The conductivity is defined as how easily the charge can flow through a material. So as the name implies, conductors have very good conductivity, and if you apply voltage across a conductor, charge would flow. Copper, iron, silver and gold are few examples of good conductors. On the other hand, insulators have very high resistance and they do not conduct electricity at all. Rubber, glass and plastic are the example of insulators. So the electrical conductivity of semiconductor is in between conductor and insulator. It means it allows moderate charge flow, and if we increase the temperature or add impurities in it, its conductivity will enhance. Because of this property of semiconductors, they are widely used to manufacture electronic devices. Silicon, germanium and the gallium arsenide are the example of semiconductor materials. Now consider the example of silicon, which is the most commonly used semiconductor material, to understand its behavior. Silicon has atomic number 14, which means it has 14 electrons, out of which 4 are valence electrons. It means there are 4 electrons in its outermost orbit. In its solid form, silicon atoms arrange themselves in crystal-shaped pattern. Each silicon atom shares its 4 electrons with the neighboring atoms. In this way, by sharing the electrons, these silicon atoms forms the covalent bond. Now, at room temperature, some of these electrons may get enough energy to break these covalent bonds and become free electrons, leaving behind a vacancy or a hole. These free electrons allows current to flow when we apply voltage across it. Now the semiconductors are classified into two categories, intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductor is the semiconductor in its purest form, that is, without any impurities. On the other hand, in the extrinsic semiconductor, the external impurities are added to change the conductivity. This process of adding impurities is called doping. Depending on the type of impurity, the extrinsic semiconductors are further classified as P-type or N-type semiconductors. In P-type semiconductors, trivalent atoms are added to pure semiconductors. Trivalent atoms have 3 valence electrons. It means when they make covalent bond with silicon atoms, one hole remains in its outermost orbit. These atoms are also called acceptor atoms. Thus, by adding trivalent impurity, we increase the number of holes in semiconductor, which increase the conductivity. In P-type semiconductor, holes are in majority and are called majority carriers, while electrons are called minority carriers. Boron, indium and gallium are examples of trivalent atoms. Similarly, in N-type semiconductors, we add pentavalent atoms to pure semiconductors. These atoms have 5 valence electrons, and when they make covalent bond with silicon atoms, one free electron is created. So by adding pentavalent impurity, we increase the number of free electrons in semiconductor and increase its conductivity. These pentavalent atoms are also known as donor atoms, as they are donating one extra electron. In N-type semiconductor, electrons are in excess, so they are called majority carriers, while holes are known as minority carriers. Examples of pentavalent atoms are arsenic, phosphorus and antimony. So these are the basics of semiconductor. In next video we'll learn what happens when we combine P-type and N-type semiconductor. So if you like this video, please like, share and subscribe. Thank you.